In section 2.6, we're going to be solving inequalities. There's a rule that we have to remember. It says if you multiply or divide both sides of an inequality by a negative number, you must flip the symbol. So we're going to solve, graph, and write the solution in interval notation. The first thing is we need to solve. So on the left, I'm going to add like terms, and I get negative 3y plus 16 greater than or equal to. Add like terms here, and I have 8y minus 6. I have variables on both sides, so I start with the smaller variable, do the opposite of it. Whatever you do to one side, do to the other. 16, then we have 11y minus 6. We want to get y by itself, so now we add 6 to both sides, and we have 22 is greater than or equal to 11y. Divide both sides by 11. 2 is greater than or equal to y. I'm going to rearrange this so that the y is on the left, the variable's on the left. When I do that, I need to be careful and make sure that if the arrow points to the y, it needs to point to the y here so that I do not change the value but rewrite it. Y is less than or equal to 2. Now if I have a graph, I have 2. Because this is a less than or equal to, it's going to have a bracket and shade the way the arrow points. Arrow points to the left, you shade to the left. Interval notation, I need to describe that. So that's going to be negative infinity, as I read left to right, negative infinity to 2 with a bracket. This next problem is a compound inequality, and I want to solve this middle. I want to get x by itself, so first I need to subtract 1. But whatever you do, you have to do on both sides since it's compound. So I have negative 4 is less than 5x. It's less than or equal to 2. Now I still want to get x by itself, so I need to divide everything by a 5. Well, whatever I do to the middle, I have to do to both sides so that it's consistent. So I get negative 4/5 is less than x, which is less than or equal to 2/5. So that's what goes over here in our solution. Next, we want to be able to graph this in order on the number line. Negative 4/5 comes before 2/5, so I need to put these two in order. This one's going to be a parenthesis, and this one is going to be a bracket because of the bar right there. And it says, we read this as x is greater than negative 4/5. So if it's greater than negative 4/5, it means I'm going to be shading this to the right. And this says, but it's less than or equal to 2/5. So it's going to be less than or equal to. So our portion that we shade that describes both of those, meets both of those classifications is that. And then our interval notation is just parenthesis, negative 4/5, 2/5, then we have a bracket. Now we have an OR inequality. We want to solve each one of these individually. So we get 3x is less than negative 6, divide by 3, x is less than negative 2. On this side, we're going to do the same thing, solve for x, and we're going to get 1/2. So x is greater than or equal to 1/2. And we bring down our OR, so this goes over here in our top solution. Now negative 2 comes before 1/2, so I'm going to put that there. Next I will have x is less than negative 2. So that's going to give me a parenthesis, and if it's less than, I'm shading to the left. And this one says x is greater than or equal to 1/2. So because it's an or equal to, I have a bar and it's going to be shaded to the right. So as interval notation, I need to describe negative infinity to negative 2 with the bracket. Union picks up with the brace, a bracket, and it goes to positive infinity. So I have negative infinity, negative 2 with the parenthesis, and then I have 1/2 with the bracket to positive infinity, and that's our interval notation. Okay, absolute value inequalities, if you want to read these real quick, basically, in a nutshell, if it's less than or less than and equal to, it's going to be an and problem. If the original problem is greater than or equal to, it's going to be an or. These point to the right. These right here, the arrow points to the right and the word or has an R in it. So that's how I usually see it. So this one is not pointing to the right, so it's an and problem. Okay, whenever we do absolute value, you're going to have, I'm going to go ahead and put in that answer side. X is less than 5. You write it exactly the same. And X is, you're going to flip the inequality symbol and make it a negative. Okay, every time. So then, if we look at example 2, when we look at this one, we're going to do X is greater than 5. You write it one time exactly the same. And then the second time, you're going to flip the inequality and make it a negative. Now, since this one's pointing to the right, it's an or problem. Okay, now let's go back and graph each one of these. So if I have negative 5 is first on the number line, then positive 5. If this is going to be an and, it says X is less than 5. That means it's less than, that's everything this way. X is greater than negative 5. That means everything higher this way. So we need to represent that. They're both parentheses. And we shade this middle portion. Interval notation is just parenthesis, negative 5, parenthesis, positive 5. On our second example, we put these in order according to the number line. It says X is greater than 5. That's a parenthesis. That represents X is greater than 5. And this one is X is less than or equal to 5. This one gets a bracket. Oh, I didn't need to add that less than or equal to in there. So this really should be just a less than. I don't know why I had that equal to. So just less than, because the original problem didn't have an equal to. So it's just going to be a parenthesis and less than negative 5. So that goes here. Okay, now we want to describe that in interval notation. So interval notation is going to be negative infinity to negative 5, parenthesis, union. It picks up at 5 and goes to positive infinity. Okay, make sure you go back and make that correction on this and take that equal to bar off of it. Okay, our last problem, if it's absolute value, we're going to rewrite it one time exactly the same without the bar, and we write it the next time 3x plus 5, but we said we flip the inequality symbol and make it a negative. Okay, now since this is not pointing to the right, this is pointing to the left, it's an and problem, so we want to subtract 5. We get 3x is less than negative 1. Divide by 3. X is less than negative 1/3. Solve the other side. Okay, when we solve, we get x is greater than negative 3. Now to write our answer, we're going to put x in the middle. This one is, since negative 3 is smaller, we're going to put it on the left, and negative 1/3 over here. Now this is saying x is greater than negative 3, so we need x to be greater than negative 3 and x to be less than negative 1/3. So that's going to be it. To graph it, x is greater than 3, the negative 3 is going to be to the right, and x is less than negative 1/3. It's going to be this way. So we shade that portion in the middle, and our interval notation is simply those brackets.